Hello everyone, today we'll talk about the solution of the problem shifting letters to. While this problem is not that difficult, it's also not too easy, and it probably requires a bit of experience in solving algorithmic problems, or at least the ability to perform, let's say, multiple steps of reasoning in order to solve it. Because the first step that we should take is that our shifts, where we shift from the start up to end, either forward or backwards, that shifting can be thought of as just addition or subtraction, and in this case it's addition or subtraction modulo 26, modulo the size of the alphabet. Well, assuming that a is 0, that is. So we have to shift maybe the ASCII code in one direction, then perform the operation, then shift it in the other direction. But either way, it's essentially just addition and subtraction. And now, if you have some experience in solving, competitive programming problems, then you know that it's a pretty wide range of techniques that solve a problem that asks us to add or subtract values on some ranges of our array, and then we want to ask about the final state of that array. There are many maybe tricky data structures that allow us to do it, but in this case we have a very specific instance where all the operations happen one next to the other, and there is only a single query. Only at the end we want to know how the final array looks. And in that case we don't actually have to use any data structures, any segment trees or binary index trees or anything like that. We can simply use a difference array, and in that case we would have a data structure, quote unquote, that allows us to perform range updates in constant time and queries in linear time. And we don't care because we have only one query, so linear is fine, and then we are very happy for our processing of shifts to be performed in constant time. And the idea is simple. Instead of performing the addition or subtraction on the whole range, we can perform essentially the trick from calculating cumulative sums or prefix sums, and add 1 to some other array where the interval starts, and then put -1 right past the point where that interval ends. And notice that if we do it for all the shifts, so we are just adding 1 when it starts and subtracting after it ends. Of course, we have to modify it if the direction is different. Then at the end, when we calculate the prefix sum of this array, then the final value of every position in the original array is exactly the original value plus the value in our prefix sum array. In other words, we have constant time updates because we just update 2 different points, and at the end we calculate the prefix sum, and we don't have to explicitly do it, and we combine the prefix sum with the original array. So we'll be maintaining an array of diffs. So at first it's 0 for every shift. We put the difference add position start in our difference array, and we subtracted 1 past the end. And of course we want to either add 1 if diff is 1 or -1 if diff is 0, so we can just write 2 times diff minus 1. And now we'll be maintaining our prefix sum, our rolling sum, and creating our result. For our original character and the new difference, we update the rolling sum by that difference. We could use modulo here, but it's not necessary because we have to use modulo here either way. And now we take the character, we want to update it by the rolling difference. So we take our character, we subtract, so by ORD we convert a character to its ASCII code. We subtract the ASCII code for A, so now A is 0, B is 1, and so on. We add our rolling difference. We take it modulo 26 so that we stay between A and Z, and we have to then create a character out of it, so we run char, but we have again to shift it back so that A becomes A, so we just add ORD of A back to it. So we subtract it here, we add it here, and the reason why we do it in such a weird way maybe, because here we have modulo. So we have modulo after subtraction but before addition. At the end we have a list of characters, so we create a string by joining it with an empty string, and that's the whole solution.